Welcome to the Upright 2 tutorial for the Cell Imaging Facility Core at the Cross Cancer Institute. In this tutorial you will learn about the startup and shutdown procedures as well as how to use the microscope and acquire images using the software Metamorph. As for all our imaging equipment, to start up the system, follow the provided instructions. First, push the button on the power bar to turn it on. Then, turn on the lamp X sight on the shelf about the scope. Flip switches 3A and 3B, also located on the same shelf. Next, turn on the microscope, then the camera, and finally the computer. Once booted, log into the PC with the facility credentials, then log in with your personal PPMS credentials. Until you pass the training, you will not have access to the equipment. Start the Metamorph software. Bring the stage to a loading position and load your slide. Tap the left upward arrow to bring the stage back to a working position. Push the slider next to the eyepiece in and bring your sample in focus. If you wish to image at a higher magnification than 10x, make sure you only apply immersion oil to the correct objectives. If you forget which ones use oil immersion, tap the microscope tab on the display, but always use the software to switch objectives. To use the 40x, slide your sample out, apply a drop of oil on your cover slip while the stage is in the loading position. Slide your sample back in and bring the stage back to the working position. Make sure a meniscus between objective and cover slip was formed. To start image acquisition, go to Apps and select Multidimensional Acquisition. On the left, you see all your selected options. Work from top to bottom. Under Saving, add the description of your experiment in as much detail as you wish. This will be saved in the metadata of the image every time you snap an image, which you can find under Edit and Image Info. Then, select the directory where you want to save your images. Use a short base name. Make sure to check Increase Base File Name when file exists to prevent overwriting of files with similar names. Under the Wavelength tab you can see how many wavelengths you have selected for imaging. Adjust this number to the number of the channels you will need. In this case, we have DARP, FITC, and CI3. Under Illumination you can change the intensity, which we decoded as DARP 50 for 50%, DARP 20 for 20%, or just DARP for 100% illumination intensity of the DARP channel. Leave the gain and digitizer settings unchanged at gain 1 and 100 MHz or 16-bit for the highest dynamic range. Exposure and focus are important and need to be adjusted. We don't use auto exposure or autofocus. Finally, you have the action buttons for snapping a quick image, a live view, active regions which are only used in special cases, and acquire of the whole experiment, i.e. all your channels. If your live view is gray like this, it is because you forgot to send the signal to the camera. Pull the slider next to the eyepiece out to see your cells. The red slider in the top left corner is helpful to find your best focal plane with the highest intensity. By scrolling up and down, you can zoom in and out. The most important part is to get a good signal-to-noise ratio, which is determined by the dynamic range of the camera. Do not eyeball this, but instead measure it. When you zoom in here you can see that some nuclei are saturated and thus are outside the detectable dynamic range of the camera. This means your exposure time is too long. Start with half the exposure time. Although this looks better, there is still saturation. Another way to find the right exposure time is to start with auto exposure. Here you adjust the maximum intensity you want to achieve. 50,000 is a good target exposure. It is important to keep in mind that we are using a 16-bit camera. 16-bit means for every pixel in this image, the computer allocates a certain amount of memory or binary units. Every pixel can encode information for 16 zeros and ones and thus resolve a wider variety of intensities. In other words, the dynamic range of a pixel can vary from 0 to 65,535 in a 16-bit image. Thus, if you target your exposure to 50,000, you have some room before saturation and are able to capture and compare images of varying intensities. In this case, the exposure time would be 13 milliseconds. Another way to keep an eye on the intensity is with the glider on the left side of the image. The lower one indicates the minimum pixel value and the upper one the maximum. This is where you would want your picture to be for analysis, and the picture appears qualitatively good as well. It is important to check the numbers as this camera is very sensitive and you might not be able to judge the dynamic range properly by only looking at it. For example, if you reduced the exposure time to 1 millisecond, qualitatively your picture wouldn't change. However, the dynamic range, and thus your signal-to-noise ratio, is much lower now. This will be a particular issue when quantifying your signal during analysis. To further visualize the signal-to-noise ratio, you can perform a quick line scan by selecting the line tool and drawing a line over areas of the image that contain cells and background. Under Measure, select Line Scan, which will give you a plot of the intensity for each pixel that the line is drawn on. After we change the y-axis range to 50,000, our target maximum intensity, you can see how with this lower exposure time, the signal-to-noise ratio is very low. When we change the exposure time back to 13 milliseconds, you can appreciate the improvement of the signal-to-noise ratio in the line scan plot right away. Thus, it is much easier to detect those cells. Keeping this in mind, we adjust all our channels the same way. Once you have set this up, you are ready for acquisition. Under the Display tab, you can select to show the composite image, which you will see during acquisition. The acquisition of each channel will be automatically saved to the folder path that you set up initially, but the composite image will not be saved since you can reproduce this yourself later. If you wanted to save this particular composite image though, you can go to File and Save As. Before we move on to ZStacks and 3D image acquisition, let's clean up the workspace by clicking on the X. This will remove all your saved and unsaved image previews but keep your multidimensional acquisition window open. Under the Main tab, select Z-Series to add that tab to your options. Click on Z-Series. We start by finding the right range of our Z-Series. In a monolayer of cells, your best focal plane will be fairly similar across many areas on your slide. The range should be somewhat bigger than the average size of your cells. You can find the top and bottom of your cells by focusing up and down. Pay attention to your current position to get an idea of a suitable range and extend that range a little to make sure you are collecting all information you are interested in. Select a suitable step size and determine the looping order. The two options are to either to switch channels at each Z position, the first option, or to acquire the whole Z stack for one wavelength first and then move on to the next wavelength, the second option. Each option has its benefits and limitations, the first being the slower but more precise option for variability in Z between the channels, and the second option being the faster but less precise one. Make sure to keep the shutter open between steps as closing it will slow down your acquisition and possibly cause other issues. And voila, you acquired a Z stack. Finally, if you need a large field of view, you can scan the slide. For that, go to Apps and Scan Slide. Adjust the channels as we previously did, including the correct exposure time. The main distinction to general image acquisition is that you need to select the start and end positions, i.e. your image's upper left and lower right corners. You can find those positions by going to Live, finding your starting point, clicking Set to Current in the upper right selection. Then move to the lower right corner and set to Current in the lower right selection. Make sure to select a directory again to save the file to, and you are ready to scan the slide. Once scanning is done, click on Show Image to see the result. To clean an oil immersion objective lens, bring the stage to the load position using the microscope display. Remove your sample and use a folded sheet of lens paper to remove the oil from the lens. Never use any other tissue paper on objective lenses and never press on the lens itself. Now, bring the stage back to the working position by tapping the left upward arrow on the microscope display. Once you are done with your session, make sure to switch the objective to the 10x through the software and bring the stage back to the working position. If you are the last user for the day, follow the shutdown steps from the instructions by first turning off the microscope, both power sources, the X-sight lamp, the camera, shut down the PC, and finally the power bar. As last user of the day, also cover the microscope but never do so when the system is still running, as this poses a fire hazard.